Good morning. So today we're looking at paper 2 of the May-June 2021 DBE paper. We have in the previous video covered question 1 to question 4 of this paper. Okay? So now question 1 to question 3. So we're on question 4 now. Okay? So in question 4 we are told that in the diagram, okay, so let's pull the diagram up a bit. We're told that in the diagram, P, which is negative 3 and 4, P is negative 3 and 4, which is here, is the center of the circle. V, which is K, and 1, which is lying there, and W are the end points of the diameter. Okay, they're the end points of the diameter. So which means to say that is equal, that's equal. We can use distance midpoint theorem to calculate the coordinates of W once K is solved. Then the question, the introduction tells us that the circle intersects the y-axis at B and at C. That's your y-intercept. What do you do for y-intercept? Let x equal to 0. C, B, C, W, V. B, C, VW is a cyclic quad, which means to say that opposite angles are supplementary. Okay? Opposite angles supplementary, they add up to 180. Then we are told also that the exterior angle will be equal to the interior opposite angle. Okay? Exterior angle, and here the same story with that there. Okay? Or 180 minus alpha V. C we produce to intersect the x-axis at T, x-intercept at y equal to 0. Once I got that, I can work out this angle here. If I get the gradient of line CV, I will be able to calculate that alpha angle there. Okay. So everything that is given in the introduction is on the diagram, so we can take this introduction out. Okay. So now we're looking at the first question. So in the first question, if I had made any mistakes, please contact me on that number there. Or if I've explained something wrong, feel free to contact me on that number. Otherwise, these videos are free, and you can share it with your fellow friends or learners or whatever. Okay? Or if there's an easier way of explaining something, feel free to contact me. Okay. So in 4.1 we are told the radius of the circle is root 10. So if the radius of the circle is root 10, that's going to be root 10. Root 10, your diameter of course is going to be 2 root 10. Okay, so that's a root 10. Calculate the value of K if the point V is to the right of P. So if V is to the right of P, that means to say negative, the K value must be greater than negative 3. That's basically what that stands. Okay? That your K value is more negative than, and more positive than negative 3. Or on the, must be a value greater than negative 3. Okay? Clearly show all calculations. So in 4.1, we need to know the equation of the circle. Okay, and at this point I can work out the equation of the circle. Okay, or I can go with distance formula. Since the radius, which is PV, is root 10, okay, I can say it's going to be root 10 squared. No, root 10. We'll first write the formula down. PV is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So PV is root 10. So root 10 is equal to the square root of negative 3 minus k squared plus 4 minus 1 squared. So to get rid of the square root, I square both sides. So it's going to be 10 is equal to negative 3 minus k all squared plus 3 squared, which is 9. But I get over the equal sign. So I get 1. 10 minus 9 is 1. So negative 3 minus k all squared is equal to 1. Now I can do one of two things. I can either multiply the binomial square out or square root. If I introduce square root, plus minus. So that's going to give you negative 3 minus k is equal to plus minus 1. Variables one side, numbers the other side. So k is equal to minus 3 plus minus 1 or minus plus 1. So k is equal to negative 3 minus 1 is negative 4. Or k is negative 3 plus 1, which is negative 2. Remember what did they say? It has to be on the right side of p. So it can't be negative 4. So k has to be negative 2. Okay. So I'm going to put here v, which is negative 2 and 1. Okay, I'm going to try and keep the diagram in focus. So I'm going to erase as I go along. Okay. Otherwise, at this point, you can pause the video. That is one way of doing it. Okay. Then we could have used the fact that it's on the circumference of the circle. So the equation of a circle is x squared, no, x minus a all squared plus y minus b all squared is equal to r squared. Otherwise, if the center was at the origin, you would have gotten x squared plus y squared is equal to r squared. But as we know, the equation is not at the origin, so that is not the formula. Where a and b are the centers of the circle, which is dealing with p directly there. So we have x minus minus 3, which is plus 3, and y minus 4 all squared is equal to r squared, which is 10, root of 10 squared. Okay, I could just written 10. Now to calculate k, I could have just substituted v, which is k and 1. That's x and a y. So k plus 3 squared plus 1 minus 4 squared is equal to 10. This is going to give us 3 squared, which is 9. 10 minus 9 is 1. So k plus 3 squared is equal to 1. Square root thereof, k plus 3 is plus minus 1. So k is equal to minus 2, or k is equal to minus 1. Both ways you're going to get the full mark for the sum. Okay. So what I'm going to do is I'm just going to write the equation with a circle down here if needed further on. Okay. So as I indicated, I'm going to erase as to make space for the next calculation. Okay. Any problems so far? Okay. In question 4.2, we are told that the equation of the circle is given by okay, so the question says the equation of the circle is given by. Now you see this x squared plus 6x plus y squared minus 8y plus 15 equals 0 is derived from this equation here. If I multiply this out, I get x squared plus 6x plus 9 plus y squared minus 8y plus 16 equals 10. So that's going to give you x squared plus 6x plus y squared minus 8y. 10 is going to give you 6. 9 plus 6 is 15. So that, what they give us here is derived from the equation that we have. Okay? So what I'm going to do is I'm going to take this off here. I put this simplification one there, so it's x plus 6x. Okay. Calculate the length of BC. So for BC, what do we need? We need the coordinates of B and C. Okay? So what is B and C to us? They are our y-intercept. So again, I'm going to use, I could have used any one of the two. So I say y-intercept. What do we do for y-intercept? We let x equal 0. we always need to work with what is given to us. Since that was given to us, I use that. If you had used the other equation that we have derived ourselves, would have, and the equation was correct, you'd get the same answer as well. Okay? So if we do the substitution, I'm going to get 0 squared plus 6 times 0 plus y squared minus 8y plus 15 equals 0. So what happens is, this cancels. So this is now a trinomial. Okay? So again, people, don't keep yourselves brave if you can't factorize a trinomial. Use the quadratic formula. Okay? So we have 1, negative 8, 15. That gives us a y value. And some people write x when they use quadratic formula. Watch out for that. So y is equal to 5 or y is equal to 3. So which point is which? B is 0 and 5, and of course C is 0 and 3. So therefore, what is the length of BC? So BC has to be 5 minus 3, which is 2 units. Okay. Then, let's get the next question. You can use distance formula there, but it's not really needed there because it's on your y-axis. You see that? So your x is constant, so it's going to be the difference of the y's. If it's on your x-axis, then there will be difference on your x's because your y's are constant. Okay? So let's look at this question. In 4.3 we are told, let's change our color. So 4.3 we are told if k is negative 2, which now confirms what we have there. Okay? And say for argument's sake you have made a mistake or you got a different answer, check it again. Otherwise, if you're still convinced that your answer is right, you have to use what is given to you, which is negative 2 anyway. Otherwise, if you use anything other than negative 2, you're going to lose the mark immediately. Okay? So, we are told if k is negative 2, calculate the size of theta, or alpha, sorry. The size of alpha. So, to calculate alpha, we need to know that tan of alpha equals the gradient. And the gradient of this line, which is CV, or TC, or whatever. Since we got the coordinates here, we're going to say change in y over change in x. So tan of alpha equals, remember, this is an acute angle by the looks of it. So it's going to be 3 minus 1 over 0 minus 2, which gives me 2 over 2, which is 1. So arc tan of 1, shift tan of 1, arc tan of 1 is going to be 45. Arc tan of 1, that's forming from your special triangles, special angles. So that gives me 45 degrees. So this angle here is 45 degrees. Okay. Then in 4.3.2, in question 4.3.2, they ask you to calculate the size of VWB. So VWB, this angle here. Okay? VWB. So, this angle here, we indicated already, will be equal to this angle here. How did we know that? Because this is now a cyclic quad. We were told earlier on, this is a cyclic quad. So exterior angle is equal to the interior opposite. That is coming from Euclidean properties, okay? Euclidean geometry. So, if we look at what we have, okay, we have just calculated this angle here, 45. Of course, that is 90 degrees. Why? Because you got your vertical and your horizontal. It's always at 90 degrees. Then this angle here can be calculated. Okay, now this angle here is equal to that angle there, because that's vertically opposite, and then of course that angle is equal to that angle there. Okay? So let's lay that out. You're going to first say that, of course, TCO, we don't have to say that's 90, so we're not. If this was Euclidean geometry, we'd have to say that is 90. Okay? So every statement needs a reason in Euclidean geometry, but it's not analytical. So we just say that TCO, angle TCO, is equal to 45 degrees. Why? Sum of triangles in this triangle. Okay? It's 45 degrees. Okay? You don't need a reason, but I'm going to put here sum of triangles. So there's 45 lying there now. Now, instead of saying that is vertically opposite to this angle, what I'm saying is that this is the extension of line CB or BC. So that is also an exterior angle to that triangle there, and to the cyclic quad, sorry. Can you see that? So that angle is also 45 degrees. So VWB, that angle is also 45 degrees. Why? Because it's an exterior angle of cyclic quad. Okay. Exterior angle of a cyclic quad. Okay. So again, you don't need the reason here. You're not going to get a mark for the reason. I think there was 2 marks allocated. Here's 2 marks on the sum. So you would get 1 mark here and 1 mark there. Unless the question says, with reason, state. And then you'd have to give you a reason. Okay. But that was not the case. So the reason was not required there. Okay. I needed to take it off again. Let's delete that. That is 4.3. Question 4.4. Let's get the other part here. So in the next question we are told that a new circle is obtained when it's given. Circle is reflected about the line y is equal to 1. Okay, just take this out here. So a new circle is obtained when the circle is reflected about the line y is equal to 1. So what I do is I draw that line in as my guide. Okay. So if you got y is equal to 1, this is 3 here. So here's 1. Y is equal to 1 will go through this here. As you can see that y value is 1. Okay? So that is y is equal to 1. So if we reflect this in this line, then this point remains that point. Okay? Then this point of negative 3 and 4 distance from there to there is going to be, the coordinate here will be negative 3 and 1. Not so? Because that's now on this line. So if I reflect it and fold it close in this line y is equal to 1, then that point now would fall 4 units down, no 3 units down, because it's 3 units down, because that distance from 4 to 1 is 3. 3 units down. So that will be from 1 minus 3 is going to give you 2. So it's negative 3 and negative 2. So the center of the new circle will be at negative 3 and negative 2. Understand? Okay? You look at it again. Don't look so convinced to me. Let's go again. Remember, it's reflected in the line y is equal to 1. So what I do is I draw that line y is equal to 1 into the graph, into the diagram, as my guide. Now you see the circle here. Let's see if this is going to work, this explanation. Draw the circle, exactly the same circle. What's happening to the circle? It's reflected in this line. So I don't know if I can reflect this with you. It's reflected. It's going to have to be translated. It's not going to work very well. Okay? This means to say it's reflected in a line y is equal to 1. So it's going to look like that now. You see, in this line. If I fold the circle close in this line y is equal to 1, the circle, this top part here, this part here, will fall exactly onto this part here. And of course, this part here will be that part. Not so. So that is reflected in that line y is equal to 1. So that the circle that is drawn in is what we are talking about. So, they want to know the coordinates of Q. Where is Q? The center of the new circle. Okay, Q is the center of the new circle. So if this is your original circle, so we take it from there down to this point of reflection. How many units down is that going? 4 units down, 3 units down, not so. Why? Because it's going from 4 to 1. So it's 3 units down. So if I move 3 units down, I must move 3 units in that direction because that's a reflection. So that's also going to be 3. Not so. And 1 minus 3 is negative 2. Let's look at the, negative 2 on your y. Alright? But what is your x value? Negative 3. What's your x value here? Negative 3. What's your x value here? Negative 3. So that is your q value. Negative 3 and negative 2. Okay? I'll just take this away. I'm going to replace it in blue. Okay? We go from there to there. To here. That's going to be, what was it? Negative 3 and negative 2, and this is your q. It's 4.4.1. Okay. Then the next question. Right, so we got that. Let's delete. So it's 4.2.2's question. In 4.2.2 they ask you the equation of the circle in that form. So which circle are they referring to? Q. This equation with Q as the center of the circle. Would the radius have changed? Why not? Why would the radius have not changed on the circle? The length of the radius. Because the circle is still the same size. It's only reflected. It's not enlarged or reduced. Once it's enlarged or reduced, and then that changes. Okay. So the equation of the circle in that form will be 4.4.2. will be x squared, x minus a squared plus y minus b squared is equal to r squared. Okay? So what is the center of the circle? Q, which is negative 3, that's your a, and negative 2 is your b. So we got x minus minus 3, which is plus 3 squared, plus y minus minus 2 squared is equal to r squared. And what's your r squared value? It's coming from the circle, original circle, which is 10. Okay, any confusion there? No? And then, remember, as long as the equation of the center, and the equation of the circle, and the center is not at the origin, then it follows that formula y is equal to, this formula, y is equal to, no, not y, sorry, x minus a squared plus y minus b squared is equal to r squared. Okay. And then in 4.3 the question says, let's change our color now again. So in 4.3 we are told that the equation of the line drawn parallel to the y-axis. So we're drawing a line parallel now to the y-axis. Okay? And passes through the point of intersection of the two circles. Read it again. The equation of the line drawn parallel to the y-axis. So this, if I take this line here, that is parallel to the y-axis. Okay? It's equidistant from the y-axis at any given point. So the equation of the line drawn parallel to the y-axis, passing through the points of intersection of the two circles. So which means to say this line is passing through where? Through V. Did you see that? That was the one point of intersection. And of course on the other side, which is that point B. Not so. So the equation of this line, this line, will be the x value as it is there and that x value as it is there. Not so. So, the one equation is x is equal to yes? Negative 2 or? The other one is x is equal to? Well, what was this coordinate here in line with this? Negative 3 is. So this is negative 2. So what is that distance from negative 3 to negative 2? What is that distance? 1. So what must this distance be? The same, which is also 1. Not so? So now, the equation of is actually on this point. It's not drawn to scale. But if this is negative 2, that is negative 3, then this has to be negative 4. Remember that is 1, 1. So it's negative 2 and negative 4. Right, do you understand? That was a good question. Again, if I had made a mistake, there's an easier way to explain. Please let me know that number. This official memo is not out of this paper as yet. Okay? So I could be making a mistake somewhere. Alright, let's look at question 5. Our favorite, trigonometry. Remember in this exam, because of the weighting change and COVID and all of those things, geometry has taken, has dropped 10 marks and it was given to the trigonometric or trigonometry section of it. Okay? So make sure that you know your trigonometry. Alright? So the question 5 says 5.1, simplify the expression to a single trigonometric term. So a single trigonometric term is either sine, cos or tan to us. Okay? So for 5 marks, this is a negative x. So we know that negative x is in your fourth quadrant, tan is negative. So you can just write negative tan x. But say for argument, we could use the other what's his name as well? The other argument is that if this is negative, what we do is we add 360 to it. So that is the same as saying 360 minus x, which gives you negative. Because it's in the fourth quadrant, tan in your fourth quadrant is negative. So it's negative tan x times. Cos is cos x times. Now x minus 180. There's your x angle. Minus 180 takes you to quadrant 3. So that is going to be negative sine x. But say you don't want to work with a negative angle. So what we do is we say, okay, we add 360 to that. So 360 minus 180 is 180. So that is the same as saying sine 180 plus x. So 360 minus 180 is 180. So it's 180 plus x. Okay? Which gives you 180 plus x is still in the third quadrant. Which makes sine negative. So it's negative sine x. Okay? Move that over. Minus 1. which is this minus 1 here. Okay? So we always change tan because I want to simplify. So tan can be written as sine over cos. Negative times negative is positive. So tan we say is going to be sine over cos times cos x times sine x minus 1. Now what? Cos is cancelled. Leaves you with? Are you sure?
No,
Sine squared x. So we left with sine squared x minus 1. But what does this remind us of? What does sine squared x minus 1 remind us of? Okay, go to cos squared. What is cos squared x equal? Sine squared x? No. We know that cos squared x plus sine squared x is 1. So cos squared x equal to? 1 minus sine squared x. You say, hang on, is that the same? No. So I'm going to get it the same. Is when we swap this around, the negative will come out, it becomes 1 minus sine squared x. Not so. Swap that binomial around with the negative between it, the negative comes out. So if you multiply this in, it's going to give you negative 1 plus sine squared. Can you see that? Okay. So this part here is equal to what? 1 minus sine squared x. So your ultimate answer is going to be negative cos squared x. Your final answer. Alright? Very simple. Let's look at 5.2. If you had made a mistake in the sum, you can pause the video, redo it, and come back and see if you get it right. Okay. In question 5.2, we are given that cos of 35 is equal to m. Without using a calculator, determine the value of each of the following in terms of m. So what we need to do is, we need to construct a triangle for this. Okay? So cos of 35, when we are faced with this part of the work, it's always an acute angle. So if you want, you can draw it in the first quadrant anyway. But for this part, very seldom draw it in triangle in the Cartesian plane. So cos is what? What does cos stand for? Adjacent over hypotenuse. Not so. So my adjacent is m, my hypotenuse is 1. So how do I get the opposite? 1 squared minus m squared. But how do we get that? Your Pythagorean theorem. So 1 squared is equal to your opposite side squared. So it's 1 minus m squared is equal to your opposite side squared. The root thereof, so its opposite equals the root of 1 minus m squared, which now in turn can be written as 1 minus m, correct? Can it be written as 1 minus m? No.
1 minus m squared.
There has to be. The square root can't be taken. Why not?
Because you don't have m squared.
You don't have that? No. It's because of that negative. It's like if we had 25 minus 9. Can we say that is 5 minus 3, which is 2? No. We have to first simplify that to give us 16, and 16 the root thereof is 4. So whenever there's a plus or minus between it, we can't do it. We can't take the root thereof. We must first simplify before we take the root. However, if it was multiplication, you could have taken the square root thereof. Okay. So that is our diagram. I know most of you can write this without doing this calculation. Okay. You don't have to do that calculation. Alright, so let's answer the question. So in 5.2.1, the question says cos of 215. Remember, this angle here is also useful to work out that angle. What is 90 minus 35? 180 minus 90 minus 35? Should be 55. Just in case there's a 55-degree angle that we're going to work with. Okay. So, cos of 215. Which quadrant is 215 in? Third quadrant. How do you get in the third quadrant? So it's 180 plus what? 35. You say, hey, there's your 35 degrees. Can you see that? So, what happens here? All stations to Claremont. 180 plus, that takes us to which quadrant? Third quadrant. Stand cos is positive or negative? Negative. So it's negative cos 35 degrees. Now we say, okay. I know some of you also do it. Without that, you don't have to do this. You can leave it out, no problem. There's no mark allocated for that. So cos stands, what does cos stand for? Adjacent of hypotenuse. But we know from the given ratio that cos of 35 is m. So the answer is negative m. Okay. Let's look at 5.2.2. In question 5.2.2, they ask you for sine of sine of 20 degrees. Where does 20 degrees fit in here?
Sine of
90 minus 55 is what? Check, what's 90 minus 55? 35. 90 minus? But remember, we got a 20 degrees here. We must bring 20 degrees into the story. Isn't 55 minus 35, what is that?
20.
That is 20, not so. So in other words, we can say this will be sine of 55 minus 35. But now what does this remind us of? What does this remind us of? Double angle. This should remind you of sine alpha minus beta equals sine alpha cos beta minus sine beta cos alpha, or cos alpha sine beta. That's your compound formula. So that gives us, I don't need this anymore, I'll take this off. So that gives us sine alpha, which is 55, cos 35, minus cos 55, sine 35. Not so. So what is sine 55? Sine 55. Here's your angle. Sine is opposite. It's going to be m over 1, which is m. Cos 35. Adjacent of hypotenuse. So it's m over 1. Minus cos of 55. It's adjacent, which is 1 minus m squared over 1. Times sine of 35. It's adjacent, is opposite of hypotenuse. So it's the root of 1 minus m squared over 1. In other words, I'm left with m squared minus. Now you see, under the root is the same. So that is, in other words, the square root of 1 minus m squared all squared, where the root cancels that. Not so? So that will give us 1 minus m squared. So what happens now? We can multiply this in, which will give us m squared minus 1 plus m squared, which is 2m squared minus 1. Okay? Okay, what just came to mind was another way now. Okay, I'll do it this way as well, just to give you a feel of a different way of doing it. Might look a little bit long, but I'm seeing here, it reminds me of the cos double angle. So what I'm going to do is I'm going to change this to cos. So this is sine of 20 can be written as cos of 70. So sine 20 is sine 90 minus 70, which is cos 70. That's your correlation. Now what relationship exists between 70 and 35? It's twice the angle, it's double angle. So in other words, we got cos 2 times 35. So now what comes to mind? What should come to mind is the formula cos twice alpha is 2 cos squared alpha minus 1. 1 minus 2 sine squared alpha. And cos squared alpha minus sine squared alpha. One of those three. So since I got cos given to us, cos is given to us, I'm going to go with the first one. Okay? You could have used any one of those three, because we have this triangle here. So that triangle you can use sine, cos or tan. However, if you apply this here, it's going to become 2 cos squared. What's my alpha angle here? 35 minus 1. What is cos of 35? M. So it's 2m squared minus 1, which gives me the same answer as I had in the previous one. Okay? So I'll carry on in the next video. Next time. Okay?